Welcome to clickmyproject.com.
Now we discuss about a process of a transformerless grid connected photovoltaic system based on the coupled inductor single stage boost 3-base inverter. In this process we use the coupled inductor for boost the DC voltage level, and then we use single stage inverter for convert the DC voltage into the 3-base AC voltage. The 3-base AC voltage will be connected to the grid for analysis the process. Here the DC voltage will be generated by using the PV cells. The PV cells is the one of the renewable energy sources. It will be give the DC voltage with eco-friendly, and also it is the noise level will be low, and then that coupled inductor will help to boost the PV cell DC voltage into certain level, and then the MPPT controller will be used the PV cell for maintain the PV cell voltage at constant level. That here we don't use any transformers, so that reason the coupled inductor will be boost the voltage level. If we use not transformer, so that reason the losses will be reduced in this process. So that reason finally the leakage current will be also reduced. Then we use the 3-level inverter for convert the DC to AC conversion. So that reason the harmonic will be reduced. That 3-base inverter will control based on the pulses. We use the non-state pulse width modulation for control the overall inverter system. The grid we consider the different load with a different active power and reactive power, and then finally we measure the what is the voltage of the grid and what is the leakage current and what is the output voltage level will be measured, and then it is compared to the VDE 012611 standard for our output will be the accurate or not. Then we go to the flow diagram for it is the flow diagram for our proposed work. In this flow diagram the PV cell output will be go to the MPPT tracking. The MPPT tracking will be level the PV cell output with a certain level. Then it will go to the inverter side. Before the inverter side, the coupled inductor will be boost the PV cell output, and then the switches and the inverter will be convert the DC voltage into the 3-base AC voltage. The 3-base voltage will be connected to the grid, and we give the reference signal and then compare the voltage signal. Then we generate the pulses. That pulses will be control the switches to maintain the 3-base AC voltage at regulator. It will be reduce the harmonic level for our process. Then we go to for the project demo. Now I going to demo of our process. In our process the Simulink model will be designed based on the PV cell output. The PV cell output will be generated based on the irradiation value. In environmental, the irradiation value randomly changed based on temperature, but the Simulink model it is not possible. So that reason we generate the random value for irradiation. That irradiation will be go to the Simulink PV cell block. In the PV cell block it will be solved based on the basic PV cell equation, and then we generate the PV cell output voltage. That PV cell output voltage will be go to the coupled inductor boost circuit. In the coupled inductor boost circuit here there are 4 diodes and 3 capacitors and 1 inductor, and also the coupled inductor. The diodes will be held to reduce the resisting current, and also the free wheel diode will be used, and then the capacitor will be charging and discharging based on the voltage level, and then the inductor will be reduce the harmonic level, and the coupled inductor generates the or boost the DC voltage will low level to high level. After that voltage boosting, it will be going to the 3-level inverter. The 3-level inverter, there are 6 switches will be used. The switches is the IGBT switching. That IGBT switching by control the gate signals. The gate signals will be generated by the control circuit, and then that inverter will be convert the DC voltage into the 3-base AC voltage. That 3-base AC voltage will be connected to the grid throughout the inductor and also the resistance, and then the resistance will be reduce the voltage level, and also the inductor reduce the harmonic level. After the 3-base inversion will be done, it will be connected to the grid. In that grid, there are different types of active and reactive power load will be connected with parallel and series conditions. After the load, we measure the 3-base voltage, and using the 3-base measurement, we calculate the common mode voltage and the base voltage and the line voltage and the leakage current, and also the space vector will be calculated, and that common mode voltage and the leakage current will be limited in the standard level, and also that base voltage and line voltage will be the low harmonic level, and then it is the 110 voltage. Now we go to see the control circuit. In the control circuit, we give the reference signals, and then we compare to the reference signal. It will be generate the gate pulses. That gate pulses will be controlled to the inverter, 3-level inverter, and it will be reduce the harmonic level in our overall circuit. This type of transformerless photovoltaic based grid connection is the key of future grid connection. In our proposed is the one of the process to generate the power for grid by using the renewable energy source. It able to increase the power consumption level with low cost and less noise. So in our proposed type of grid connection is here eco-friendly, and result of the circuit shows our proposed work gives a better performance result compared to the given standard level. So that we use this type of transformerless grid connection will be improve the better result for grid connection history. Thank you.